Yeah, welcome from my side. I have the great honor to re-energize you after lunch. I hope you knew about that we had to wait for Windows Update. That was the reason you came late in, I hope. Yeah, I'm going to introduce a very valuable and powerful new player in the domain of big data. To be honest, myself, I'm not a great expert in big data analytics. I'm going to introduce energy system to you as a new player. And I'm going to present a rough image of what's going on in the domain of energy to give you an impression what could be possible together with big data analytics. My name is Karl Knöbl. It's not easy to spell it. I'm sorry for that. And I'm coming from University of Applied Sciences, Technikum Wien. We are named, located in Vienna, as you can imagine. We educate more than 4,000 students, have 14 bachelor programs and 17 master programs in operation, and we are ranked #1 in Austria, not only in terms of size. Yeah, and I, in person, plan for the next minutes to present this. The first, I try to interpret for myself what could be possible with big data together with the energy system. Then I go more into the domain of energy systems, mainly focusing on electrical grid and point out the current driving forces, what are demands on interoperability. This is the first hint to my program where I'm very engaged in. And then I go down to the methodology we defined to react on current challenges in the energy system, going for interoperability in an increasingly heterogeneous world of energy we are facing. And that's the methodology we inherited from the e-health, where we could learn along. They have a perfect interoperability validation process scheme in place, and we learned a lot from them. Even the validation tool, this is called Gazelle, where an automized interoperability validation could be done perfectly and efficiently. As I then show in very special events. The one we were invited is the Connectathon in The Hague in April. We have been there, where all relevant providers and suppliers meet and try to successfully interoperate on new use cases. This is a very special process with a special spirit. The developers come together and in the end, they help each other from different companies to get successful interoperability. This is a very curious process I had to learn there. Then I tried to give my analysis on the specifics on the data we can gain from the energy system. As we learned before lunch, it's very important to know about the causalities and interdependencies and cross correlations of the data you fetch. And this is one issue which is very important in the field of electrical grid. Okay, that's my simple understanding. Big data is for me, you have a source of information and you collect that seemingly meaningless information, and upon aggregation and perfect analysis, you get valuable information out of it. This is, of course, even possible with the electric grid, which is going to be digital, which is going to have human interaction, thinking on home energy management systems. We have a lot of information we can collect. But I'm quite sure that we even can benefit from aggregated information when going for profiles, load profiles, when forecasting some loads, which gets more and more complex because humans interact, for example, to optimize their self-consumption of their solar energy when switching on remotely with the mobile. the heating machine or whatever. Okay, the driving forces, mainly 3 of them. In the European Union, we subscribed to climate protection, and a lot of effort is done in that field, ending up in going for renewable energy resources, prioritizing feed-in from renewable energy sources, even in the local low voltage distribution grid. The next is the single market, going for a liberalization. It was a very complex act to split the energy trade from the energy transmission. This was a basic condition, otherwise we couldn't get liberalized this market, because the one who owns the grid has the power to rule the market. And the third is the general increasing digitalization of everyday life, thinking on home energy control appliances and such things. Okay, we are facing challenges of the kind that the consumer gets to produce energy. This artificial term was created expressing a producer, an entity which consumes and produces. We have to handle volatile energy sources. Solar energy is, of course, depending on irradiation and cloudiness. Even the wind is volatile, not dependent on fuel, so we have to handle somehow this volatility. We get an increasing component diversity, different vendors, different types of management systems, mobile apps and whatever. We got a complex market structure by this unbundling of trading and transmission domain. And we get more possibilities, but more problems with increasing information communication technologies. And European Union tried to get it managed and issued the mandates. The one is the mandate 490, which grouped a group of researchers. They shall go for what could that smart grid we are thinking of really be. And please try to make an architecture model to localize every actors, every players which are important in that field. And they took this very generic methodology to find an architecture model. I don't like to get too deep into. This is a cyclic process starting with an architecture vision, going down what sales guys think about this architecture or what they need, the business architecture, going down to information modeling, information system architecture, having with the technology architecture a first draft, let's say, from an architecture model, and on analyzing new opportunities and new possibilities, coming in with technological development and what else. They have to come to new change requests to that architecture model, and this circle will repeat. And the end, this was the model, the smart grid architecture model, having 3 dimensions. The one is the domain, which reflects more or less the historic energy flow from the left-hand side, bulk generation down to the customer premises. Introduced already within one cycle the decentralized energy resource as one entity which feeds in power on the low end of the grid. The second dimension is the zone, which is reflecting more or less the information aggregation deepness, starting with the processes, which are control loops and measurement processes, simple information collecting or actuators, which is aggregating up to a field station to an operation center. One can imagine a SCADA system having everything in hands on the facilities of a grid operator. The grid operator itself is dealt with an enterprise. He himself operates on the market. So this is a kind of data compression, data aggregation dimension. On the other hand, we have, similar to the ISO-OSI 7-layer model, we call it interoperability layers. On all of them, we need to ensure, to validate interoperability. On the component layer, it's clear, plugs must match. On the business layer, more or less clear, you need one who buys your service or your product. In the middle, we have, for example, the function layer, which outlines use cases where you can explain the function in the dependency of some steps of business cases. Yeah? Only to shock you, this is one flat representation of this model and an impression how complex it is. If you press one of that yellow buttons, you get an endless list, you can see it on the square bar, of protocols, of standards. Yeah? Each of them is a very complex document, is relevant for this place and for this interconnection. And you get even use cases which play a role for that entity. Okay, so somehow we have to ensure interoperability. And we, in our Austrian research project, IES, Integrating the Energy System, at least in Austria, but we had also interaction with European partners. We have even one of those guys which designed that model in our project as a partner, so we are well set up and we have had the first official presentation in The Hague, as I already introduced. And this is a model of the workflow which we partially inherited from the world of e-health. So where vendors and users meet in an annual cycle on two levels, on a management level, on a developer level, and define new use cases which are relevant for the market. Sales guy rule us in this case. In a second step, technicians and sales guys go and define that integration or interoperability profiles in a very standardized way. Even the definition of a use case may follow strict rules. A maximum number of actors, a maximum number of transactions is given to keep a use case granularity to be managed with that annual cycle. Minutes later, the developers come up with a solution, with an implementation, and they meet annually on that interoperability conformance testing event. And the results are published publicly on a website and finally build a valuable information for any procurement if you go for devices which are able to run a virtual power plant, for example. You can have a look on that site and you find companies which are able to provide that and already succeeded in interoperability tests. Okay, we picked up a use case for demonstration. This is a virtual power plant. Currently, everybody knows in the energy domain. This has a lot of fantasy for new business cases. This is briefly explained an aggregation of small physical generators, PV power plants, to a large but virtual power plant, which is then able to deal on the market to offer energy and even reserve restoration services to the market. So we have our own system to define use cases. Everybody knows the UML kind of designing use cases. We have tailored a very specific methodology which was standardized under that name and reflects the needs, the specific needs for the energy system. For example, we picked out one use case which is called send a schedule. This operator sends a schedule out to his decentralized unit in order to fulfill his profiles which he had agreed on the market. He sold a given profile and he requests his units to drive exactly that profiles. So we had to localize it, and I already introduced the function layer is the one where we can see that use cases, and we found those steps, those use cases to be part of this virtual power plant operation. We selected mainly those three. I don't go down to that very details. Send the schedule to the decentralized energy unit. Okay, and according to the rules they gave us from the energy system and were well established in this domain, we defined that use cases in a first step on a business layer, on a high level, what has to be done, and went down to a technical implementation which goes for existing standards and how to use them, how to configure them, how to parameterize them. We didn't define new standards. There were sufficient standards in the field. We only wanted to profile the application of a standard. Yeah, we went for actors, transactions, together building an integration profile. This is more or less a scheme which we well know from UML definitions. And brought the technical view together with the salesman's view in one document. Too much details for today. We decided to use a very special standard. This is that 61850, very famous in the field of energy systems, because nobody wants to implement it because it's that complex. It's a standard for information modeling only, and has only references to standards how to communicate with partners. It's a very complex standard, and we tried to succeed with that, and we did. Okay, and we went to write it in a document with a strictly given document structure that eases the process of then validation, the interoperability, and explaining. We had a business case overview where you can go to non-technical experts who have to decide from the simple salesman business point of view the necessity of such a use case in the very first step of this process. Okay, interoperability testing, the test event. Based on that document we developed, we got a list of, we defined the list of test steps in our test tool and a special validation concept, how to validate the right semantic and syntax of the messages to be conveyed. And in the end, we had this happens then in this annual event. We had to instantiate tests. That means we will. My device has to implement 3 test instances at least with remote partners to get this flag that I succeeded interoperability test. In each test instance, I analyze each message. We had to transform, because this is not like in the world of medicine, a text-based protocol, but we even had to always had to struggle with bandwidth. This is ASN1 coded, abstract syntax notation 1, and basic encoding rules, so not that easy to interpret. And we had to transform it to XML with daffodil transformation, and then we could validate this with a schematron pass. Okay, a validation result, passed or not passed, complemented then the list of test instances between 2 partners. Okay, this happened in Den Haag this year. By the way, a very good place to go, unless you have not a very special reason to do that. The court for war criminals is even there. We met at the Fokker terminal where they built airplanes before, a large setting of technicians, of developers, and really a very special spirit where we helped each other to succeed with interoperability. Both it's a win-win situation. Both want to get partners which they have as communicator. And that were us. So 5 minutes before breakthrough about that. Okay. In the end, we get. I already referred a list of products publicly available. You needn't engage Procter & Gamble for 100,000 euros to make a market study which products are in the field. You get a list for procurement as an input for marketplace where they can select products and buy. That's a simple list. iageurope.org, connect.on result. For example, healthcare, we didn't provide that yet. You can find companies and the use cases and go for such crosses and find your products which you can then order. Okay. On preparation of the slides, I had some thoughts on what makes the data you get from the energy system specific. The one is we handle a hybrid grid. We don't have only data coming independently. We learned we need to know about causalities and cross correlations amongst our data. So we always have an electrical grid in parallel to the data grid, let's say. If I measure there and there, those values, even if similar, have probably only one interference, the electrical grid, because they depend on it, each other. Yeah? So we have to be aware of this fact. And we will go for more interaction. We call it sector coupling, where we connect energy in terms of sources, electric energy, heating energy, cooling, gas, the carriers on the one hand, and even from the user side to mix them up, to utilize flexibilities, to utilize better storage capacities, facilities. Electric energy is perfectly to be transported in nearly light speed, but not the best to be stored. The one speech before mine referred to the Austrian benefit of having that pump storage devices, but if we go for the Austrian consumption, one of the largest is emptied in 1.5 days. So it's perfect to do a short-term buffering, but not really a seasonal storage. Yeah. But we can, for example, power to X is a term where we make from an energy from a current surplus, which we have Sunday afternoon, early afternoon, when nobody needs power and sun is shining or wind is blowing. We have a total surplus which we have to pay for if somebody is grateful and uses this power, and we are going to make gas out of this energy by hydrolyzing water, mixing it up, tell me that in that simple way with CO2 and get methane and alcohols out of it, which we can perfectly store even over seasons. So we have further interactions to be considered in terms of sources, so the carrier and even the users. And we are controlling a critical infrastructure. It's not about a simple buying a book or selling a book, but we control with that information a really critical infrastructure, a power grid. We should have this in mind whenever we use aggregated data for controlling something in the grid. Okay, some links. IES Austria is the project I talked about mainly. If you have this information given in a female speech, you can go for that link. We gave a webinar, a European, by the way, the first SNET webinar ever, and she could it better than me, but nevertheless. Okay, that's me, and that's the end. Thanks for your attention.
Okay, thank you very much, Karl. Do you have any questions? Okay, then I got one. So, Karl, did you consider in the energy management the water consumption and water source as a renewable energy source?
Sorry,
the water.
Water source.
Yes.
Yes, we drive a renewable energy institute, and there we think about every kind of renewable energy, wave energy. Osmotic energy, you know, if you bring salty water together with non-salty one, you can utilize the osmotic pressure to generate power out of that. We analyzed all of them. There is a website, e-genius.at, where I provided a lot of information concerning the potential new energy sources we have to consider. But at the moment, the sources which are on highest technological readiness level are, in my opinion, the photovoltaic and the wind. Photovoltaic has a benefit because there is no mechanical movement. This is a simple assembly, a plate. The pity is that you can't assign some emotions to that rectangular black thing, so you can't do advertisement on that. Everybody goes for windmills and other things, but you can't advertise that. But I guess those are the most prominent technologies which can help us towards a totally renewable energy system.
Great, thank you very much.